Okay, here we use the amount formula for continuous compounding. That is, A equals P times E raised to the power of RT, where A represents the amount after T years, and P is the amount deposited, and R is the interest rate in decimals, and T is the time, and this is in units of time. It is years, minutes, hours, like that. So here we are given that P is $350. That is, the amount deposited at the beginning is $350, and the interest rate R is 4.5%. So first, let's convert this interest rate into decimals. So 4.5%, and this equals 4.5 divided by 100. We replace percent by divided by 100. So this equals 0.045 in terms of decimals. This is 0.045. So we found or we converted the rate in percent as decimals, that is 0.045. And also it is given that after certain time period, the amount grows to $700. That means we represent A equal to $700. So in this situation, we have to determine the time. That is, how long does it takes for the amount to reach $700. So let's substitute these values into the formula. I'm going to replace A into A as 700. So therefore, this becomes 700 equals, and replace P by 350, that is the amount deposited, and E raised to the power of, replace R by 0.045, and then multiplied by T. So we can solve this equation for T. First, I divide both sides by 350. I divide by 350, and here also I divide by 350. So we see that these two 350s gets cancelled, and 700 over 350 is 2 times. So we get 2 by 1, which is 2, and this equals e raised to the power of 0.045 t. So we have to solve for t. This is an exponential equation. We can apply natural logarithm to both sides. So natural logarithm to both sides so that we can solve for t. And when I do that, I get natural logarithm of 2, and this equals natural logarithm of e raised to the power of 0.045 t. Now, using the properties of natural logarithm, that is the power rule of natural logarithm, we can bring this power in front and then multiply with natural logarithm of e. So we have natural logarithm of 2 on the left side, and this equal to 0.045 t times natural logarithm of e. Remember that the value of natural logarithm of e is 1. So replacing this quantity, that is natural logarithm of e, this quantity by 1, the right side expression becomes 0.045 t times 1 is basically 0.045 t. This is 0 times 1, it is 0.045 t. So we can solve for t. We have to divide by 0.045. So therefore, I rearrange after solving for t, and this equals natural logarithm of 2 divided by 0.045. We plug this into the calculator, and when we do that, we get this is approximately, I can put this as approximation, 15.4, and we put the unit of time, that is years. So it takes about 15.4 years for the amount to grow to $700.